Okay. All right, good morning. I think we're good. We live? All right, can you hear me, Anthony?
Yes, I hear you.
Right.
Good morning.
Morning. I think we're good to go. So what we do. Okay, 1 second here. Let me get my screen ready. Okay, can you see the presentation?
Looks good, Mario.
All right, fantastic. All right, I believe we're good to go. Well, first off, I'll start with saying good morning and thank you for joining our presentation. Let me see, make a couple movements here. All right, apologize. Just getting things together here. Again, thank you for joining our presentation this morning, allowing us, myself and Mr. Anthony Chambon, to showcase a little of what Tecumseh has to offer. My name is Mario Gauna, and over the last 7.5 years, I've been an application engineer with Tecumseh Compressor Company. I've been assisting our OEM customers here in North America with Tecumseh powered solutions across a wide range of applications. Anthony?
Thank you, Mario. Good morning, good evening, everyone. My name is Anthony Chambon, and I have been an application engineer at Tecumseh Laboratory for 5 years. My focus is to support our customer in the development and testing of sub-150 GWP refrigerant alternatives, as well as other low GWP solutions. I will be really excited to present you some case study in a moment.
Definitely. Okay, well, in today's presentation, we will be understanding energy reductions that are possible with Tecumseh's R290-based AL and variable speed solutions. So here at Tecumseh, we pride ourselves on being a 90-year-old refrigeration company and maintaining our core values to this day that have never changed. Our mission to maintain a position as a leader in innovative cooling solutions for a greener tomorrow. Our vision to deliver high-valued solutions to our customer and maintain a customer-driven environment to which is only possible with a continued execution of our values: integrity, passion, respect, teamwork, and excellence. Today in this presentation, we'll look at Tecumseh and where we are located across the world, look at some of the R290 solutions that we have to offer, observe a few case studies and the added benefits of converting existing applications over to a natural R290 refrigerant solution, and then conclude with a review of the potential energy savings that we can provide with our R290 options. As one of the largest producers of compressors and condensing units in the industry, Tecumseh has multiple offices and thousands of locations present now on 5 continents, with manufacturing facilities on 4 of these 5 continents. As you can see here on the slide, we are spread across the world to support your refrigeration needs. To begin, we'll review some of the new R290 options that we currently have available in our portfolio here at Tecumseh. On this slide, excuse me, I would like to focus your attention on the various refrigerant applications that our products can excel in. We have great small fractional horsepower compressors like our TC optimized, and AEX models, but none stand out more as an excellent option like our new AL compressor does. This model is best in class and will be a fantastic option for those looking to save on energy and not compromise on performance. Also, I would like to mention our variable speed technology that we have developed specifically for our R290 refrigerant. Our VTC line of compressors are perfect for light commercial back applications, and our master flux compressors are ready to fill the void in a variety of those unique specialty applications that you might need a solution for. We'll revisit these 2 optimized compact compressors a little later in this presentation. Nonetheless, if there's a commercial application that you have or are looking to develop, Tecumseh can help with that. Now here on this slide, I would like to highlight a couple of our new and exciting developments with R290 refrigerant. The TCW and the TCX and the ALX models, which I've touched on the last slide. All of these compressor options offer expanded evaporator range and increased performance efficiencies, while our variable speed technology continues to improve with the VTC options for the IntelliCool platform and our Masterflux DC models, which are reaching into a higher voltage range and will be able to offer even more solutions for a list of potential applications. Also worth mentioning here is that we have a sub 150 GWP A2L compatible compressors currently available in the European market today. Here at Tecumseh, we're ready to improve or help with improving a lower GWP solution and incorporate our solutions into your applications for a greener tomorrow. To start off our natural R290 refrigerant portfolio, I'd like to show you our TC line of compressor models and highlight some of the great features that it offers as a compressor family. So to begin, the TC has been evaluated and designed with efficiency and overall performance in mind, while keeping the standard suction and discharge tube connection ports, along with a compact physical footprint. This helps with allow for installation and serviceability. Our TC compressors are approved to cover both low and medium back pressure applications, designed to operate with motors that are equipped to handle a range of voltages and frequencies. The TC compressor models are available to support various refrigerant solutions across the world. Currently, motor options are offered for this compressor line in the 115, 127 volt, 60 cycle single phase, and or a 220 volt, 240 volt, 50 hertz single phase option. Also to include this in this model is a 220 volt single phase for both 50 and 60 hertz. As for performance expectations, the TCW and the TCX compressor models are offered with an improved extended evaporator range that I mentioned earlier, allowing for a green solution to excel in either low back or medium back applications. All are designed to operate at the -35 to -5 degrees Celsius range, or -31 to 23 degrees Fahrenheit. For those applications that require low back conditions specifically, there's also a TC model option available for that too. With displacement ranges from 2 cc's to 8 cc's, the TCW and TCX options are versatile enough to be applied to a large range of applications. At ASHRAE low back conditions, our TCW compressor capacity starts at 300 BTUs per hour and go up to 1,750 BTUs per hour, with efficiencies reaching into the high 4 to 5 EER range. While at ASHRAE medium back conditions, we offer capacity ranges beginning at 650 BTUs per hour and go all the way up to 3,400 BTUs per hour, with efficiencies at this condition in the 7 to 8 EER range. These options are available with either high or low starting torque motors, depending on the needs for the application's specific design. On this slide here, I want to get a little deeper into our new optimized TCW compressors. So we look at what makes this Mighty Mini an ideal choice for beverage coolers and chest freezers alike. So the optimized window, this compressor takes the optimized window with the already extended evaporator range and implements a redesigned motor targeted on saving energy while maintaining the increased performance capacity, giving you a standardized solution for both low and medium back applications. This newly designed configuration is perfectly suited for static or fan-cooled applications and will open a wider range of energy savings with no compromise on performance for many applications that are currently existing or in development and ready to be applied around the world. At Tecumseh, we understand the need for eco-friendly solutions that are more now than they have been, obviously, in the past. Our new AL maintains industry standard suction and discharge tube locations to facilitate the ease of installation and serviceability, both on the assembly line and in the field. And so our AL compressor has been specifically designed for improved performance and reliability and thoughtfully optimized to increase efficiencies with R290 refrigerant, while still maintaining the standardized compact footprint along with low noise emissions for those applications that require a quieter operation. On this slide, I want to look at a few of the AL compressor specs. Here we can see that the AL line of compressors have the potential to cover a wide variety of various applications. With a new extended evaporator range of -35C to 5C, this best-in-class compressor can cover both low back and medium back pressure conditions, proving to be a suitable solution for two different application ranges, or for one application that is designed to operate within both envelopes. With three different displacement models that are currently offered in 15, 17, and 20 cc's, and models that are available with three different motor configurations ranging from 230 volt, 50 cycle, single phase, as well as 60 cycle in both 230 volt and 115, 127 volt single phase. The potential for a game-changing natural cooling solution is right here with the AL compressor. And here on this slide is, I would like to bring to attention our VTC compressor. With our IntelliCool platform that includes this VTC compressor, this combination is another optimized platform designed specifically to excel in performance with the use of R290 refrigerant. While capable of delivering the same capacity as some larger displacement single-speed compressors, the VTC lineup compressor maintains the small physical footprint and helps with allowing more room for refrigerated goods in the end application design. Optimized for an operation at both low and medium back pressure applications, the VTC compressor is another prime example of a natural refrigerant solution that we have to offer. This highly efficient compact package utilizes Tecumseh's adaptive logic, or otherwise known as TAL. TAL is a technology that is designed to continuously adapt and adjust the speed of the compressor in order to maintain an optimal cabinet temperature, with the intent on keeping energy consumption down to a minimum. So using the TAL technology and a typical on-off thermostat gives you the perfect opportunity to replace a fixed speed compressor over to a variable speed solution without changing any additional configurations in the refrigeration system. Available compressor displacements for the VTC are currently ranging from 3 cc's to 12.5 cc's, and power inverters are available in the 350 watt, 600 watt, and 900 watt options. Here is a top-of-the-line energy-saving natural refrigerant solution that will cover a wide range of applications in the light commercial market. Sticking with the variable speed theme, I want to bring to light a little bit on our master flux compressors. These compact performers also have the potential to be a contender in the natural refrigerant discussion. We currently have 24 volt and 48 volt DC controller solutions available and are approved to operate in a range that covers both the medium and high back pressure applications. This compact variable speed compressor offers capacity ranges from 4,800 to 19,000 BTUs per hour with our CC displacement model, CC range compressor displacement model. The versatile capacity range, the versatile capacity range and compact profile of this Masterflux R290 solution makes it ideal from everything from marine air conditioning to electronic cooling systems to solar powered refrigeration stations and a lot more. I should also mention too, with the horizontal Masterflux rotary configuration in the mix, the application possibilities are plentiful with Tecumseh's new R290 lineup of compressor solutions. Not only do we provide a top-of-the-line compressors, but for eco-friendly condensing unit solutions, we have those covered as well. So Tecumseh offers a line of R290 condensing units that represent the industry standard and are readily available to cover multiple application ranges in the refrigeration market. Various compressor families are incorporated into the Celcion 2.0 condensing unit line, all of which are designed specifically optimized for R290 and to increase efficiency while reducing energy consumption across a wide range of capacities. Offered with multiple evaporator bases options and steel-based configurations, there's plenty of room for any additional add-ons that may be needed to achieve natural refrigerant solutions. Not to be outdone, I definitely need to mention our complete refrigeration systems, also known simply as our CRS units. These are completely customizable, and here in North America, we will pre-charge these units with a necessary R290 refrigerant amount that is unique to the end application. As a pre-charged system, this will help with eliminating the need for any necessary expenditures and will arrive completely optimized specific to the desired application and target temperatures. Tecumseh's CRS units are compact, portable systems tailored to a variety of specific installation requirements and considered a safe, natural refrigerant drop-in solution throughout the market. So next, we are going to review a few case studies with an emphasis on the benefits, the performance gains, and with what R290 solutions that Tecumseh has to offer, the ones we kind of just reviewed. To help walk us through the first two case studies, I would like to hand this presentation over to my friend and colleague, Mr. Anthony Chambon.
Thank you, Mario. I'm going to talk about a case study carried out on a self-contained ice machine in our Tecumseh laboratory. This study was aimed at converting and comparing a competitor propane equivalent compressor to our new best-in-class R290 AL compressor. The studied ice machine belongs to the 200-pound class ice machines. It is pictured here on the right. The unit makes 56 medium gourmet ice cube per cycle. Each ice cube is 30 millimeter in diameter by 34 millimeter in height and weighs about 20 grams. Once produced, the cubes fall into the bin, whose walls are depicted in white on the picture. The bin capacity is 48 kilograms and can be accessed by the flipping door located on the top. The ice machine is energized in single phase, 50 cycle, and the 220-240 voltage range. The refrigeration system is powered by a hermetically sealed reciprocating compressor. The ice machine came with a competitor equivalent compressor and runs on propane refrigerant, or R290, and the refrigerant flow is metered by a capillary tube. The ice machine rear view is pictured here. The compressor compartment is located on the bottom, just below the ice bin in white. Now you can see a close-up of the Ielix 430U compressor that we set up into the ice machine for the purpose of the case study. The evaporator is located on the top of the unit. It is made of reverse cups that give form to the ice and on which the evapor coil is brazed. Water is sprayed underneath until the cups are entirely filled with ice. After that, a solenoid valve forces hot gases coming from the compressor to the evaporator in order to harvest the ice cubes. The ice machine features an accumulator at the evaporator outlet. It aims at storing some liquid refrigerant that could spill off the evaporator and preventing it to flow back to the compressor. Let's discuss now why you should choose the Ielix 430U compressor for the 200 pounds ice machine class. Compared to the competitor equivalent compressor, the Ielix 430U exhibits an additional 3 cc of displacement while keeping the same physical size. With the AL compressor, you will be able to improve the cooling capacity of your system while keeping the actual size of the compressor compartment. No extra room is required. In addition, the compressor footprint is the same as competitors, so there is no need to drill or punch additional hole to set up the AL compressor instead of the competitor one. Another interesting fact is the improved compressor performance at the rating point, both in terms of cooling capacity and COP or EEA as well. For our case study, let's compare the Ielix 430U compressor to the competitor at EN 12,900 rating point. The bar chart on the left side compares the cooling capacity. The Ielix 430U delivers 1,093 watts at the rating point, so it is 18% more cooling capacity than the competitor equivalent compressor. On the right side, the bar chart points out the compressor COP and EER at the same rating point. You can see the Ielix 430U is 21% more efficient in COP than the competitor and reaches an efficiency of 2.3 watts per watt. The chart shown here is a map of evaporating and condensing temperature. Evaporating temperature lie on the horizontal axis, while condensing temperature are on the vertical axis. The yellow thick line depicts the set of conditions under which the ice machine operates during a freezing cycle. This yellow line can be understood as a path that the ice machine follows from right to left during a freezing cycle. The orange shape is the approved operating envelope of the competitor compressor. This is the area where the compressor is able to operate. As you can see, the ice machine does not operate entirely within the approved compressor envelope since the yellow path goes outside. The persisting operation in this fashion could damage the compressor. Thus, the competitor compressor is not appropriate for the ice machine operation. The Ielix 430U compressor exhibits an operating envelope here shown in blue that perfectly fits the yellow line. This has been made possible because it is a low-medium back pressure compressor. Thus, the compressor operates optimally throughout the freezing cycle, avoiding any damages in the long term. That is why the Ielix compressor is the best choice for ice machines. I am going now to focus your attention on the ice machine performance. The ice machine has been adapted in order to get the best performance from the Ielix 430U compressor. The adapting process dealt with capillary tube resizing and selection of a proper amount of propane. This is summarized here in the table on the top. The baseline is the machine as it came to us. The 1.2 by 1,800 millimeter capillary tube has been changed to 1.5 by 2,500 millimeter. Likewise, the adapting process yielded to select an amount of 90 grams of propane instead of 99 grams in the baseline. The bar chart on the left shows the ice production rate. The ice machine with the Ielix 430U compressor produces 13% more ice than the baseline. Indeed, the ice production has been increased from 72 kilograms per day to 81 kilograms per day. In the same time, the power consumption shown on the right has been decreased from 174 watt-hour per kilogram of ice to 164 watt-hour per kilogram of ice. In other words, the ice machine running the Ielix 430U compressor allows 6% more energy saving compared to the baseline. And finally, we carefully paid attention to the produced ice quality during the process of adapting the Ielix compressor to the ice machine. Note that we have gotten the same high quality crystal clear ice cube compared with the baseline as on the picture. Now I'm going to speak about the second case study on a beer cooler merchandiser for Latin or South America. The studied cabinet pictured on the right is a single-door beer cooler merchandiser. The internal volume of about 570 liters allows to cool down 196 beer bottles. This cabinet is designed to work on a below 0 Celsius temperature, ranging from -6 Celsius to -2 Celsius. Due to the very high ambient temperature in the tropical regions and the low cabinet temperature, the compressor operates in a more severe condition than usually met with this type of application. In addition, the cabinet requires a defrost device, here an electrical defrost. It is energized in single phase 220 volt 60 cycle, and the temperature control is on-off. The refrigeration system runs on propane or R290 and include fin and tube heat condenser and evaporator, and uses a capillary tube as an expansion device. The case study aims at comparing fixed speed and variable speed Tecumseh low medium back pressure compressors. The baseline is a Tcw 417U fixed speed compressor, which has a displacement of 8.867 cc and the cooling capacity of about 1,700 PTU per hour. Performance are compared with a VTCX 14U variable speed compressor powered through a 350 watt inverter. Note that the compressor displacement is lower than the baseline, only 6.06 cc, and the cooling capacity as well, just 1,000 BTU per hour. Testing with the variable speed compressor is carried out with 93 grams of R290 instead of 80 grams for the baseline. I am comparing here the merchandiser behavior during a full loaded pull-down test. The left-hand side graph deals with power consumption in relation to the time. The red line is the power drawn by the fixed speed compressor, whereas the blue line refers to the variable speed compressor. The fixed speed compressor power peaks at 700 watts about 45 minutes after the pull-down test beginning. Then the power continuously decreases up to 660 minutes of run when the thermostat starts turning off and on the compressor. The two shrinks at 240 and 480 minutes are time-controlled defrost. Regarding the variable speed compressor in blue, the power consumption is steady at 400 watts due to the inverter power limitation. From time 600 minutes, the power input is adjusted by the speed compressor, by the speed of the compressor that controls the cabinet temperature. The chart on the right depicts the cabinet temperature profile plotted against time. As you can see, in spite of different behavior on power input, the temperature falling rate is equivalent either with fixed or variable speed compressor. So the pull down is achieved in the same time fashion. But what about the overall power consumption? The power consumption is highlighted here in two different ways. The graph on the left shows the energy saving in relation to the time. As we have seen previously, the pull-down is the same both with variable speed and fixed speed compressor and took about 900 minutes or 15 hours. Here we can notice energy saving are achieved from the beginning of the pull-down test. The bar chart on the right is a balance figured out at the end of the pull-down test. The overall power consumption is reduced from 6,800 watt-hour to a little bit less than 5,100 watt-hour. So the variable speed compressor allows 25% energy savings compared to the fixed speed compressor without affecting the pull-down time. Now, how about the temperature holding test? After having completed the pull-down, the cabinet is let running to evaluate the power consumption while it keeps all the product at the targeted temperature. The cabinet power consumption is here shown with a similar pattern as previously. Because of the difference in power input, energy savings up to 15% can be reached in daily power consumption by using a variable speed compressor instead of a fixed speed one. In this case study, the daily overall power consumption is decreased from 3,000 down to 2,500 watt-hour per day. In conclusion, although the variable speed compressor has less displacement and cooling capacity, the cabinet pull-down behavior remains unchanged while achieving significant energy savings, up to 25% during a full loaded pull-down and up to 15% in daily power consumption. Now I hand off the floor back to Mario, who is going to present the last case study on an ice merchandiser.
Thank you, Anthony. Yep. And as mentioned for our last case study, I'd like to review the benefits of converting an existing outdoor HFO refrigerant application over to a natural eco-friendly R290 solution. In this study, we'll look at two different solutions. One, our Celcion 2.0 condensing unit, and for our second, our new complete refrigeration system that has been custom built for this ice merchandiser application. The subject of our case study is a 2.8 cubic meter ice merchandiser unit that is typically found outside of your local convenience stores or gas stations. This unit is designed specifically to use with 510 grams of R448 refrigerant and incorporates a 0.5 horsepower hermetic compressor with a capillary tube as the metering device, along with a 9.5 millimeter tube and fin condenser coil. For our first natural refrigerant solution, we evaluated Tecumseh Celcion 2.0 condensing unit. This 0.5 horsepower condensing unit has been optimized for R290 and incorporates a 5 millimeter tube and fin condenser coil. The only modifications that were needed to be made to this cabinet was slight adjustments to the capillary tube in order to achieve an optimized R290 charge amount of 138 grams. With only the minor capillary tube adjustments needed for our testing, the condensing unit paired up great with the existing evaporator coil that was already located inside the ice merchandiser box. Now for our second natural refrigerant solution, we applied the custom-built complete refrigeration system, and this system was pre-charged and optimized with 130 grams of R290 refrigerant. So as a completely self-contained unit, this system comes equipped with both the evaporator coil and the condenser coil. In doing this, we were able to increase the internal usable volume of the ICE merchandiser and provide a scenario that required no need for complex OEM R290 charging equipment. Also, as a self-contained system, no further modifications or existing cabinet configurations were required or needed for our evaluations. Tested at the ASHRAE 72 DOE energy conditions, we've seen significant reductions in energy consumption along with the reduction of the total amount of refrigerant needed to optimize this application. 70% less refrigerant by volume was used to maintain optimal cabinet temperatures in both of our case studies done on this outdoor application. Not only is the refrigerant reduction amount a bonus, the GWP value for the converted R290 refrigerant is significantly lower than that of the existing R448 refrigerant, testing in our baseline setup that we had originally received. Another notable observation was the Celcion 2.0 condensing unit that performed with an energy savings of 40% less than the original configuration. And while we increased the amount of internal usable volume with a complete refrigeration system, we still recorded a reduction of energy consumption to 34% when compared to the original configuration. Both of these energy saving solutions, the Celcion 2.0 condensing units and our pre-charged CRS options, are currently available in certain regions today. Ready to help with reducing the GWP refrigerant footprint currently existing in the world, here at Tecumseh, we can definitely help you be a partner for a greener tomorrow. So as seen in this presentation, we have a full range of eco-friendly R290 refrigerant solutions to cover most of your refrigeration needs. From our new AEL compressor family to our new variable speed line of compressors, Tecumseh has natural refrigerant options ready to reduce the energy consumption and increase performance output, as well as lower the global impact of your applications. And from the system side of the commercial refrigeration industry, our optimized products like pre-charged R290 complete refrigeration systems that help reduce with unnecessary capital expenditures and our condensing unit options that are completely compatible with existing configurations are ready to help you lead the way for a better future. So at this time, I'd like to thank all of you for attending today's presentation and taking the time to learn a little more about Tecumseh, what Tecumseh has to offer with our energy reducing R290 products. For more information on our natural cooling solutions, please contact your local Tecumseh representative and we'll start the Q&A. So thank you.
Thank you, Mario.
Thank you, Anthony.
I think now it's time to the Q&A session.
Yes.
Let's review if we have some.
There we go. Stop sharing. I think I did good. Am I still sharing?
I think we have done a very good presentation since we do not have any question yet. Maybe it's coming. Oh.
Okay. Well, I do want to make a point. If there's any further questions in the future or anything you might have, feel free to email us at tecumsehmarketing@tecumseh.com. Again, that's tecumsehmarketing@tecumseh.com, or visit our website at www.tecumseh.com. So
the first question, I guess, are your variable speed compressor available in Europe? Yes, of course. We have the Masterflex range of products, which is available in Europe, and also the TC, the VTC range, which is also available in Europe. Second question, how do you see natural refrigerant R290 development for transport refrigeration application for the future?
Yeah, I don't know too much for the future. I know there is, I mean, at least here in my region in particular, there is stipulations to where they can be applied based on the flammability of the R290, but a lot of like, let's say food trucks, for example, that require refrigeration have these, but not necessarily for the mechanics of the vehicle in terms of R290 being applied as a cooling solution. Hope that answers the question.
In addition, there are some customers that are implementing our variable speed compressor with propane in some transport refrigeration applications. So it's currently done. So it could be also done in the future as well.
See, in terms of power input. So there's no, so in terms of power input, I presume Master Flux would be a better choice since it has a DC motor, right? I'm going to say yes. I am not the expert in the Master Flux selections that we have, but that I believe so. I'm not 100%. We can look into that and provide you back with a reply. Anthony, I don't know if you might be familiar with the Master Flux in terms of power consumption based upon our solutions that we had to offer. Yeah. Sorry, I hope that helped. Presentation available. Yes, I believe the presentation will be available on the LinkedIn for ATMO World Summit, as well as Tecumseh's LinkedIn available site. The question was, is this presentation available? And do we have case studies for refrigerated display cases in the US market? We do have case studies. I can tell you there has been work been done on them and ongoing work being done with some, all pertaining to R290 products that we showcased today, as well as products that we'll have available for the future.
An additional question on the other channel. You said that no R290 factory charging needed. How do you manage the safety problem usually emerge with R290?
Let's see here. Safety problem usually with R290. Yeah, this is going to be, I can't answer this particularly, not being necessarily close to the production aspect of it. I do know that we have these currently available in, well, it's, yeah, I don't know. Sorry, I'm not necessarily sure how to answer that without misleading you. Let's write that right there. Okay.
Do you think the introduction of an electronic expansion valve may further improve the overall efficiency of the system you have shown? I'm not entirely convinced. I do think the efficiency is much more linked to the efficiency of the compressor itself. The expansion process could be a capillary tube or an expansion device. Sorry, expansion valve. It doesn't matter. In fact, it will just act on the superheating at the evaporator outlet, and about the risk of refrigerant spillover. So I do think it's much more linked to the efficiency of the compressor itself, as I said.
Yep, agreed. So what is the equipment level of R290 condensing units? Not sure I understand that question. Equipment level in terms of what we're utilizing in our R290 condensing units? Is that accessories? Okay. Oh, well, obviously our everything, all the accessories that are applied to our R290 condensing units have to go through the safety factor. It will not be applied in our units if they do not pass them. Other than that, if they're suitable through the specific agencies and are required for the application, we can incorporate them into our R290 condensing units in order to utilize, or in order to achieve your target temperatures and requirements. Hope that helped. Okay. Okay, it's the VTC compressor controlling program designed to turn off the compressor in drop-in applications when a thermostat cuts out. Or is it supposed to keep running or modulate to keep the product temperature set point? It is designed to keep the compressor running when required. So once your product temperature is satisfied, the VTC will shut off. Again, this whole the whole TAO algorithm is with respects to energy consumption. So it has a learning base that understands when the need for cooling is more prevalent than others. Say, as when everybody's asleep, the cabinet stays closed, the compressor will either off or idle at a very low RPMs to maintain product temperatures, to where during a rush hour, it will run if needed to maintain product temperatures. So hope that helps.
Yes, this is the main advantage of the TAL technology is just plug and play. So you put our variable speed compressor with the TAL controller instead of the fixed speed compressor without any changes on the thermostat side. And the algorithm evaluates the cooling capacity required and adjusts the speed accordingly. And it shut off the compressor if there is no load at the evaporator. So it's a smart modulation, speed modulation.
Oh, here, hold on a second. How does Tecumseh plan to be ready for commercial refrigeration future with possible REACH regulations in future EU markets? Do you have anything to share today in case of a ban of refrigeration of PTFAS? There will only be natural refrigerant, commercial refrigeration. As far as I can see, Tecumseh would offer two for portfolio commercial. Does my interpretation correct? This progress in AC2 portfolios. Well, Anthony, what did you, for the European market?
Complex question.
There's
definitively. We are believing in A2L refrigerant for I would say for larger cooling capacity, because as you know, R290 is limited to a small amount of charge, and CO2 solution today are not able to go down a given cooling capacity because they are complex and not suitable in some situations. So to fill the gap, we have the A2L range of products, and we are believing it will be the solution for the future in this specific range of cooling capacity, just above R290 and just below CO2.
Great.
And it's another topic is actual refrigerant, but it's not the focus of this conference. But I would like to mention it works well on our system. We have a lot of case study on this, and I can confirm it is a good solution.
Okay. Master Flux series with R290 as he proposed, mainly for motivated applications, automotive, and so on. Why not commercial refrigeration instead of piston variable speeds? Pros and cons. I do not believe that they're restricted specifically for automotive applications, although you know, the added whatever, I don't know exactly the word for it, but there is some more electrical components involved with the master flux. Again, DC is target for direct current, in particular with these automotive type of cooling systems. There should be no reason why I wouldn't be able to see one being applied into a commercial type of market. Again, it is a rotary specifically, and we do have a horizontal master flux compressor in the works right now. So there, I'm not sure if that helped or not, but there's the pros and cons to them. I mean, obviously are going to be based off the efficiency and your energy consumption as well as your power input.
In addition, I would say the master flux in commercial refrigeration could be useful for buildings which has solar panels or battery systems, because you do not have power consumption from DC currents to AC currents. Sorry, how can I say that? Yes, you do not have you can directly use the current from the solar panel or the battery to power the compressor.
Yes, correct.
It could be an advantage for the master flux.
Yep, solar power configurations, geothermal configurations, and the such. Definitely, I've seen some of that happen with our Tecumseh master flux. Okay. Do we have any more?
To add another comment of on the last question, we are studying energy savings we can reach with a cabinet and solar panels compared to a very basic solution, not variable speed, fixed speed, and running on the main. So this is a study we are currently doing. So as you can see, we are studying the question.
Okay. That's one. All right. We'll hang out a little bit longer and see if there's any more questions. We still have 33. No hands raised.
No more questions.
Oh, here's one here. Do we anticipate an increase of 150 gram charge limit in the US? Yes, I mean, I would. I know it's going to be, there's talk about it. There's going to be a lot of regulations and things of that sort. It probably won't be till 2024, 2025 would be my guess. Now, I'm not an expert on the subject in particular with regard to the regulations, but we've talked about it internally and it's been evaluated. Hope that helps. What do you have to do in case the complete refrigeration system runs out of refrigerant or gas? Is it rechargeable? It's a great question. I believe there should be ports on them. Again, these units are completely customizable, so they're tailored to the OEM the OEM design, application design in particular. Man, there should be ports on them, and yes, that would be in that case rechargeable with a specific amount of refrigerant, identified, obviously optimized for that cabinet. Awesome. I hope that answered your question. Let's see. The next page. Okay. All right. Well, I mean, I don't know if there's any more questions. Let's see. All right. Well, again, if you do have any questions moving forward, or you think about something later on, please feel free to email us at tecumsehmarketing@tecumseh.com. And once more, I'd like to thank you for your time, your patience, and your understanding, and for showing up to the presentation today and learning a little bit about what Tecumseh has to offer for R290 solutions. So again,
there is another
is there?
question.
Awesome.
Yeah. Is there a significant improvement in performance when an internal heat exchanger is used? Do you recommend that? Yes, of course. There is an improvement in the system performance using an internal heat exchanger. It's always a question of cost versus performance, but if you can afford this internal heat exchanger, you can reach better performance. Sure, it is. We have some studies that show that, and yes, if you have the opportunity to use it, it could improve the system improve the efficiency of your system.
Okay. One more question. All right. Yeah, definitely.
It is always a matter of cost, but sometimes it is recommended to ensure proper superheat. What is the minimum recommended superheat? For our compressor, we recommend to have at least 10K of superheating. Would be better if it's 15K. So in the range of 10-15K, it's good.
Anything about payback time, fixed speed versus variable speed? Ooh. Okay. No, I mean, I can't per se. I'm not necessarily tied to that end of the industry, if you will. I'm in from the engineering standpoint. I can tell you the performance wise and the difference between the two. But in terms of payback, the question was the payback, fixed speed versus variable speed. I'm not the person to ask on that one, but I can reach out, or if you'd like to shoot us a question at Tecumseh Marketing, Tecumseh Marketing at Tecumseh.com, I'm sure that can be addressed and give you a better idea of what the paybacks will be for the particular question. Sorry.
It is POE oil you fill R290 compressor with. I guess it is.
I believe it is. Yeah, some of them. And again, they're specific to application. We might use, I believe it is POE oil. Yes. PO.
PA or PAG, no, PAG is hygroscopic oil and not good for corrosion issues. So no, it's POE.
Okay.
Last question, maybe.
That one?
We are just 4 minutes.
Yeah, it's about to wrap up here shortly. So, okay.
Okay, I think it's okay.
Yep, I agree. Again, thank you, everyone, for attending. And please feel free to visit our website and reach out at Tecumseh Marketing at Tecumseh.com. Awesome. All right. Hey, thank you, Anthony.
Thank you, Mario. Thank you, everyone, for attending this conference. And as Mario said, feel free to ask questions at the email address we provided if you have more questions.
Definitely. All right. Fantastic. Everyone have a safe and great day.